tomorrow will be better. An object of mass 2 kilograms is thrown vertically upward at an initial velocity of 10 meters per second. Find the initial kinetic energy and the potential energy at the maximum height. Also find the work done against gravity. Follow me, dear friends. Solution. Now, to find the initial kinetic energy first of all is given by half times the mass times the square of the velocity. This means that the initial kinetic energy will be equal to this times the square of the initial velocity, which is going to be half times the mass, which is 2, and then times the initial velocity raised to the power 2. So the initial kinetic energy is going to be equal to, if you do this correctly, you're going to have 100 joule. Okay, now the second question says find the potential energy at the maximum height. To find the potential energy in accordance with this formula, PE equals to mgh, which is the height, but now they have emphasized on maximum height. So we need to start by finding this maximum height. All right, we will use the equation v squared equals u squared minus 2g and then s. Why minus? Because at the initial state of the motion of this object, it is opposing gravity. All right, that is why this sign here is negative. And here in this formula, v is going to be considered 0 because at maximum height the object's velocity becomes 0 for a while before it starts falling again. Therefore, we are looking for s in this expression, s which stands for this maximum height. If you do it correctly, you will find that s is going to be equal to u squared divided by 2 times g. And if you punch and substitute values, you're going to have that h max, which is x, is going to be equal to 10 all squared divided by 2 times g, which for simplicity's sake will be considered as 10. So if you do this, it's going to give you 5 meters. So this is the maximum height we are looking for. Therefore, the potential energy at h max will be given by, according to this formula, the mass gm 2 kilogram times g, for simplicity's sake 10, and then times the maximum height, which is 5. And if you punch correctly, you will have that the potential energy at the maximum height will give you nothing else but 100 joules again. Guys, this should tell you something. This simply means that in the absence of air resistance, the total kinetic energy which we had at the start would all be converted to potential energy at the maximum height. Again, this confirms the principle of conservation of mechanical energy. I just didn't want to stop things here and tell you because you might not understand. I had to prove it like this gradually. So in essence, in the absence of resistive forces like air resistance, there's conservation of mechanical energy. Therefore, the last question which says find the work done against gravity. The work done in this case is simply going to be the change in the mechanical energy. At the start, we only have kinetic energy, and then at the end, we only have potential energy. For this reason, I want to give you the challenge, if you've understood, to drop in the comment what the work done against gravity is going to be, because tomorrow will certainly be better.